Hello and welcome to yet another video. Today we have an A520M-PRO from MSI. So this is an AM4 board. Very good to see already on the box. 3rd gen AMD Ryzen desktop processor compatible, not compatible with the 3400 and 3200G. That is written here. And let's see if the 3000G that we have is compatible with this board. We get basically everything in the box, which is very nice. We get SATA, we got the IO shield, the board, some accessories. Looks very nice. Let's get this out of here. Let's get this cleaned up and have only the board on the bench. So the previous owner told me that this board powers up, but it is stuck on a CPU LED. So when there's a CPU LED, I always suspect that we do not enter the BIOS, so that something is wrong with either the supply voltage of the CPU, or that there has been a component knocked off and there's a missing signal that should be going either from the CPU socket into somewhere on the board, or that should go to the CPU. I had that very often, that then something around the SIO is either knocked off around the CPU socket itself, or maybe even on the back side. So let's first confirm our fault that we have. I will try to use the 3000G in here first, not knowing if it's actually compatible or not. We will also be using the 4100 in here, just to see, just to be sure if the 3000G isn't compatible, we can still use the 4100, so that shouldn't be a problem. So let's see for our passive power consumption. We have 250 milliamps, which is quite high. I instantly went with the finger onto the SIO, but there's nothing heating up there. I'm just trying. I know a few things that are passively always on the board, and when I see a little bit higher of power consumption, I always look if anything heats up instantly, but it doesn't seem to. So let's press the power button and see what happens. Okay, we get an instant beep. We have 2 amps, and we get a few beeps. I think those were 3 long ones, and we're stuck on a CPU LED. Okay, then let's try the 4100 and see if anything changes. So the CPU did get hot, so I think that our CPU vCore is running. Let's see now. And with the 4100 we get a CPU LED, but no initialization, so even less amps. So I think the 4100 is not supported by this board, because there were no beeps. So I think for the 4100 to work, we would need a different BIOS. I have one more 3rd gen here, which is a 3500X. I seem to have misplaced my 3500X, but we will be going around the board now to look if there's any physical damage to the board, because I think the 3000G is compatible, because we actually had some boot codes compared to the 4100. So what I want to do now is I want to take off the mounting for the heatsink and go especially around the CPU socket first, and then the SIO on the backside, to see if there's any damage on this board. And we will do that together under the microscope, so I can show you a little bit the process of how I proceed. So let's start on the bottom left of the processor. So let's see, for all of these components right here around the oscillators. So everything seems fine right here. This transistor looks a little bit weird. Looks like it has been water damage or something like that. Let's keep that in mind. Let's go to the BIOS chip. See if anything around the BIOS has been knocked off. And all of these seem fine. So sometimes there's resistors where I'm not too sure if they still on the board correctly. Because as you can see, this one looks a little bit different. So I just use my tweezers to just poke at them a little bit and see if they are still soldered on, and they seem to be fine here. So what you always want to do as well is to look around mounting holes. If there's any damage there, or also close to the DDR slots, and especially close to the PCIe slots. So cannot spot anything that is bad here. Let's go back around the CPU socket and go to the top side, because it's way more likely to be around the CPU socket than anything else. Especially in this area, it happens a lot around the PWM controller of the vCore phases and the SoC phases. But so far, no damage to be seen. So around the CPU socket looks very fine. There's always a lot of signaling also at the top of these DDR slots that have a lot to do with CPU vCore enabling, but this looks also fine. What sometimes happens that people knock off components while trying to put in the CPU 8-pin, especially if they have it in a case where there's very little space. I've seen that happen multiple times before, but it doesn't seem to be the case this time. Let's go around the power button in the direction on the bottom right where we have left off before. It looks fine. See any damage? Most of the time damage around like these USB put-ins on the board usually don't matter. Except if the SIO is very close to here. So this is one more big point of failure. If anything around the SIO is damaged or knocked off, then the board will definitely not be willing to turn on anymore. But all of the resistors seem to be in place. This is just audio. So around audio there can be a lot of things missing or knocked off, and it wouldn't matter for booting up. I think this is Ethernet. This also doesn't matter. What happens often is that on this side there's sometimes knocked off components, but it seems to be fine here. So this is basically the whole top side of the board, because this board isn't very big. So let's go to the back side and see if there's any damage there. So now we are behind of the vCore phrase. And let's see, there isn't too much populated here. Let's see, where are the next components? This is directly behind the socket. And seems to be fine, everything here. This is now close to the DDR slots. Also fine, nothing knocked off. Now we are behind the PCH or the chipset. I cannot see any damage here. And this is directly behind or under the CPU socket. There's mounting holes for the cooler. And this is basically the last thing of the on the back side of the board. There's nothing more really populated here. So no physical damage this time. At least no obvious physical damage. So I want to flash the BIOS of this board now, because we have the option for using the pin header on the board. So we will be flashing the BIOS now using this header right here, I have a special made cable for that, so that we can instantly attach to here. And I'm pretty sure that this Windbond chip is a 1.8 volt chip, but I will be confirming that in the schematic, and I will be using the adapter, the 1.8 volt adapter, to flash this chip. And hopefully with that we get activity out of the board for also the 4100, just to be sure. So I do not get a reaction out of this board. The IC is not responding as soon as I try to connect my my cable onto there. So what I will be doing now instead of that is to desolder this chip, and we might figure out that this chip is faulty. I don't think so. There might be it just might be not possible with this particular board to flash it through the TPM header. We will see how the chip will react as soon as we have desoldered it. And what I like to do with these SMD chips is I like to apply a leaded solder first to them, because there's also the plastic connectors around them. So we have applied some flux, and now I will just get my leaded solder onto here. And what I will do is just get these contacts wet with some leaded solder, and do the same for the other side. And now it should be way easier to hot air this off. In between, I just want one more time to try my adapter, if maybe there was a bad contact, just to be sure. But I don't think it will change anything, so we will probably see each other as soon as I will be taking this chip off. So let's now hot air this chip off, keeping in mind the orientation is the bottom right is the first pin. So let's just blast this with some heat. And there's the chip off. Let's get our adapter into here. So we need this orientation. Oh. Man, second time already that I blew the chip off. Yeah, let's use a little bit more flux, that it flows better into its place. So now with the chip soldered on, let's see the contacts, that they're actually where they need to be, and that we're contacting. The first pin is contacting. I think there might be a little bit too little solder, but I think it's contacting fine. And just like here. So we should be fine with that. So let's put this into our programmer and then see if the chip then reacts. And currently I'm reading the BIOS off of the chip, this time with soldering it on. It verified the chip, so I don't think that the chip is faulty, but there was just missing connections on the board. And let's see now if it now if the flashing of the BIOS that we do actually has an effect on it, where we can actually boot or get any reaction with the different kind of CPU, so with the 4100. So I was now able to dump the original file, and now I will be programming a BIOS file off of the main website from MSI. So after reading the BIOS, I get a verification error on an address as soon as I try to write to the chip. So I will be resoldering the chip, and I will be trying a different BIOS to verify that it is actually the chip that is faulty here. So after resoldering and trying the different BIOS, I still get an error on this chip. So I will be trying to get a donor chip which is similar to this one. So what we need is a 256-bit. You can see in the bit size right here. We need a 1.8 volt chip, as you can see here. And it should be an SPI NOR 25XX. So let's see if I get one of these, and so that we can program the BIOS on it. So after a lot of searching around, I actually found a donor chip. This time it's not a Windbound chip, but it's an MXIC chip. This is also a 256-bit, a 1.8 volt chip. And before I found this one, I found another one, which is this Windbound chip, which is also 256-bit. But the problem is this is a 3.3 volt chip. So I had this one already soldered onto here. And I was detecting the chip in NeoProgrammer, and I saw that this is a 3.3 volt chip, and that I had to start over. So we now have this MXIC chip that hopefully will work on our board. So what we need to do now is to erase whatever we have on here, and then flash it onto the and then flash the MSI BIOS onto here. So the new IC is now in place. And I will be checking its solder connection, but I'm pretty sure it's soldered on fine. And let me get it built up, and we will see if we have any change now. So the board is built up. Let's now see. Passive power consumption 250 milliamps, just like we had before. And let's see now. Power button press. And we still have about the same. So the 4100 probably isn't supported on any of the BIOSes. So let's now try with the 3000G and see if anything has changed with that. And 3000G is in. And we do go further. We do go to a DRAM LED. It's now the second one. Okay. DRAM LED. Let's swap out the memory then. Let's get this into the other slot and see if we can get boot now. Let's see. Let's turn this on. CPU LED. Flashing RAM. And I think we're getting post. 2.8. Let's get a heatsink on the CPU. And post screen? Question mark. It did activate. It's flickering. And there's the post screen. Very, very nice. Very good to see. So, we got post with the 3000G. Let's now get the second stick of RAM in here and see if we can post with that. And with the second stick of RAM. Let's turn it on. And we seem to get RAM training. All of the LEDs turned off. And we get VGA. The power consumption is jumping like we want. And we get boot. There it is. Both RAM channels working. So what I want to do now, I'm going to look up if the 4100 isn't supported on any of the BIOSes, but I'm pretty sure it isn't. So we will be using the 3000G then for testing, and I want to get a graphics card into here and see if all of that then works. And currently I have the 4100 in it. Now the 4100 is also posting. Don't know what it was before, but we do have a VGA LED with the 4100 because there's no, I've currently connected to the input of the CPU, but this isn't an APU, so it complains about missing VGA. The picture that you see in the top right is a stock image. So I will be building this board up with the 4100, get a GPU in here, and test the M.2, and we will see if everything will work. So, and now the board is working. We have Ethernet connected, the M.2 is connected, we have 2 RAM sticks on there, and I will be doing some stress tests now for the CPU and then also the GPU, but I think it looks quite good. And now LinPack has passed without any problems. And this is basically our mainboard fixed. I gotta be honest, I'm not too sure what the actual problem was. If we had a stuck BIOS or if the BIOS chip was actually dead. Like, I wasn't able to write to that BIOS chip anymore, any new information, but I was able to read it. And with a different BIOS chip, writing the software onto that the board now does work. And yet again, we've been able to show that you can just change out the windbond chip with an MXIC and vice versa. You just need to be sure that the voltage is right, in this case 1.8 volt, and that the amount of capacity, the memory capacity, is the same one. In this case 256 mbits. And yeah, that or mbyte, not too sure. And yeah, I hope you enjoyed the repair. I hope you learned something. This has been Multimeter. Thank you very much, and goodbye.